Okay, so in this video, we're going to be looking at quite an interesting concept, which is referred to as rationalizing the denominator. So, just for interest, so I'll be referring to this as, for example, a square root, or this as a cube root, or fourth root, etc. However, the correct term for these, like in total, is actually to refer to these as radicals. Okay, so a radical can be basically denotes this symbol over here, but it can be a square root, it can be a cube root, and it can be a fourth root. Okay, so let's see what I mean by rationalizing the denominator. We'll say we are given something like this: 2 over square root 3. Okay. So if we look at this specific fraction over here, when we're talking about rationalizing the denominator, we want to make the denominator rational. If we're looking at this denominator over here, we have the square root of 3. And the square root of 3 is in fact irrational. If you actually type this in your calculator, you'll find that square root 3 is equal to 1.7320, and it keeps going. So we refer to this as irrational. And once you actually get to varsity, if you make the wonderful decision of doing first year varsity, you'll actually go and use a technique called proof by contradiction, where you can actually prove that the square root of 3 or even the square root of 2 or square root of 5 is irrational. And so the point is that we want to sort of change the fraction we have over here, 2 over square root 3, in such a way that we can get something in the denominator that is rational. Okay, so our problem is the square root 3 over here because it's irrational. So how can we change this fraction to get something in the denominator that is rational? Well, the technique that we'll use is simply to multiply this fraction by square root 3 over square root 3. So let's see how this works. So technically what I'm doing here is I'm not really changing anything, because square root 3 over square root 3 is just equal to 1. And 2 over square root 3 times 1 is just 2 over square root 3. So I'm not changing anything. So what I've done here is I've multiplied this fraction over here by the value in the denominator over here, square root 3. So by that value over that value again. Okay. And we'll see how this helps us. So if we actually go and multiply this out, you'll see at the top, so we have 2 times square root 3. And at the bottom, we have square root 3 times square root 3. And we know from our rules that that's just equal to 3. And now what you can see is at the bottom we now have 3. So we've literally gotten rid of that square root, or that radical, and we've turned it into a rational number. 3 is a rational number. And so this is actually a very useful technique for solving all sorts of complex sort of equations or fractions that are quite hard to deal with if we have something in the denominator that is irrational. Okay, but the key thing to look out for is the radicals in the denominator. Okay, so let's look at another example. So say we are given 16 over the cube root of 2, and we're asked to simplify this, or just to rationalize the denominator. So we know that the cube root of 2, it's not rational, and we can see we have a radical in the denominator. And so instinctively we should know that we have to apply the technique of rationalizing the denominator. Okay, so what I've mentioned before is that when we have this, to get rid of the radical in the bottom, we'll multiply this by that same value in the denominator as a fraction. So we'll have that value over here in the numerator and the value here in the denominator. Okay, but before that worked because we had a square root, and if you multiply something, a square root multiplied by a square root, with the same value inside, you're just going to get that value back. But in this case, we have a cube root, right? So to get rid of the radical, we need to multiply this again by the same value we did before. So technically, we're just multiplying everything by 1, which just takes us back to the same value. Cool. And what you'll see now is at the bottom, in the denominator, that will go and simplify to 2. And so we've changed that to something that is rational. And at the top, we'll just simply have 16 times, the cube root of 2 multiplied by the cube root of 2 again. Okay. And we know we can simplify this. We can simply divide 16 by 2, and we'll get 8. And we know that since we have the same root, or same type of radical, we have the cube root, we can simply just multiply the 2's with each other and bring them within the same cube root. So we have the cube root of 4. Cool. And that'll be your answer. So let's look at another example. So say we are given 5 over 2 minus square root 3. Okay. So, and they're still asking us to just rationalize the denominator. So we'll notice that the denominator is still irrational, because 2 minus something that is irrational is going to give you something that's irrational again. So the point here is now we can actually use the following trick in this case, because now it's not as straightforward as the previous examples where we only had a radical in the bottom. Here we have 2 minus a radical. So what we'll do is, because, I mean, if you're asked to simplify something like this, there's not really much you can do. And when you notice that you have a radical in the denominator, there should sort of be like alarm bells ringing in your head, I need to rationalize the denominator. So what we'll do in this case, you notice that we have 2 terms in the bottom, not 1 anymore. We have a 2 and the square root 3 separated by a minus. So what we'll do now is, once again multiply this by something that is technically equal to 1, but that will help us to get rid of the irrational denominator. So we'll multiply that by whatever's in the denominator once again, in the numerator and denominator. So we'll have a 2, but now instead of a minus as we have over here, we'll change that to a plus, and you'll see how that actually helps us. So we'll say 2 plus square root 3 over 2 plus square root 3. Okay. So once again, I've just taken everything in the denominator over here, and I've basically distributed over here into the numerator and denominator. So I'll be multiplying this whole thing by that. The only difference here is the minus has changed to a plus. Okay, now we can go and multiply this out. So at the top we'll have 5 times 2, which is 10, plus 5 times square root 3, which is 5 square root 3. Cool. And at the bottom, you'll see how the minus actually helps us now. Where the difference in sign. So here we had a minus and a plus, and we'll see how that helps us. So we'll first multiply the 2's. 2 times 2 is 4. Then we multiply 2 by square root 3, which is plus 2 square root 3. And here the sign difference comes into play, because now we're multiplying negative square root 3 with 2. So that's going to be minus 2 times square root 3. And you can actually see here that these two will cancel out. And then finally we'll have minus square root 3 times square root 3, which is just minus 3. Okay, and we can simplify this to, at the top we'll keep the 10 plus 5 times square root 3, and at the bottom we'll have, let's see, so the 2 times square root 3 will cancel out, and we'll have 4 minus 3, which is just 1, like that. Okay, and this will simplify to 10 plus 5 square root 3. Okay. And also just take note that our goal was to rationalize the denominator. So we started with this, which was irrational, and we got it down to 1, which is rational.